So today is pre-lab experimentary electrochemical cell, week 5. As usual, first of all, right, you have to prepare your lab report by write down your name, class, metric number, and lecturer's name, Madam Kong. So title, experimentary electrochemical cell. And then today objective is to arrange aluminium, zinc, magnesium, and copper in an electrochemical series and to determine the Faraday's number by electrolysis of copper sulfate solution. Okay, before that, okay, happy Chinese New Year, still in New Year mood, huh? Okay, I hope every one of you already watched this video, experimentary electrochemical cell. If you haven't, right, please watch it now. Okay, this is the link. Then after watch this video, please do remember, fill in the attendance Google form. So theory, first of all, right, we need to know, for this topic, electrochemistry is a field that study the relationship between electricity and chemistry. So there are two types of electrochemical cell. Okay, please alert, the general name is electrochemical cell and then divided to two. One is galvanic cell and another one is electrolytic cell. We have to know the difference among these two cells. A galvanic cell is a type of electrochemical cell where redox reaction, still remember what is redox reaction? Is the reaction of oxidation and reduction occurs spontaneously and generate electricity. So meaning that galvanic cell is from chemical energy changed to electrical energy. So for a cell that is connected by a salt bridge, oxidation happens at anode and then reduction happens at cathode. So the electron flow from anode to cathode. The standard reduction potential is a reduction potential that is obtained at a standard condition. What means by the standard condition? It means the concentration of the solution is 1.0 molar and then the gas partial pressure is 1 atm and the temperature is 25 degrees Celsius or 298 Kelvin. The potential difference between the two metals in each cell is called as cell potential. The cell potential, or we call it as cell voltage at a standard condition, can be written as below. E node cell is the standard, is the cell potential is equal to E node cathode minus E node anode. So over this formula, we have to identify which one is cathode, which one is anode. If the cell potential at non-standard condition means not 1 molar, 1 atm or 25 degrees Celsius can be calculated by using Nernst equation. So this is the Nernst equation. E cell equal to E node cell minus 0.0592 over N log Q. N is referred to the number of electrons based on the overall equation. Q is the concentration of product to the power of X over concentration to the power of Y. XY is referred to the coefficient of the overall equation. Okay, and then E node cell is, we are applying the formula that we discussed just now. E node cell equal to E node cathode minus E node anode. Next, we talk about electrolytic cell. Is a cell that use electricity to produce chemical change in electrolyte, meaning that this is the changes of electrical energy to chemical energy. The cell is made up of two electrodes connected to a battery which function as a source of direct current. Then during electrolysis, right, cation will move to cathode and then reduce, while anion move to anode and then become oxidized. The amount of substance formed at each electrode can be predicted based on Faraday's law. Okay, so you must know the difference between galvanic cell and electrolytic cell. And then the anode, cathode of the electrode, then the flow of electron, and so on. So these are the comparison between the difference of reduction and oxidation. So you can check it by yourself. Is the function of salt bridge? Okay, so the function of salt bridge is to maintain electrical neutrality and complete the circuit by allowing ion. Please take note, it's ions carrying charge to move from one half cell to another half cell. Okay, normally we are using potassium chloride, potassium nitrate, sodium sulfate, or ammonium nitrate salt bridge, inverted U tube. So procedure. Okay, please remember, draw the diagram or flow chart in your lab manual. Okay, then next week we are going to run the experiment, okay, in pair, and then we continue with post lab. Okay, means you have to prepare your lab report, change all the procedure to passive form. So for post lab, you can prepare first, so that next week you just fill in the data and then do the calculation part and discussion part. Next is about galvanic cell. So if you look at this diagram, right, one is anode. So over here, anode is zinc electrode with terminal negative, and then copper is the cathode with the terminal positive, and then the electron flow from anode to cathode. Okay, so you have to check what is the concentration of the zinc sulfate and copper sulfate. And remember, here is 35 ml. Okay, you have to measure 35 ml of zinc sulfate by using 50 ml beaker. Alert, this one is 50 ml beaker. Okay. After you take the cell potential of zinc versus copper, then you have to continue the experiment by using magnesium versus copper, replace with magnesium half cell. Then the third one is replace aluminium half cell, and the fourth one is iron half cell. Okay, must remember when we change the electrode, the solution also have to change. For this one, magnesium sulfate, this one aluminium nitrate, and then this one iron sulfate. So this is part A, discussion and calculation. So first of all, you have to write half cell and overall equation for the 4 set of experiment that we have done in part A, and determine the value of reduction potential for the following half cell. Okay, we are using copper as the reference. This is the reduction potential of copper. How to find this value later, I will show you all. Based on your result, arrange the matter in order of increasing strength of reducing agent. So reducing agent meaning that normally we will choose as undergo oxidation happen at anode with more negative value. And then state the function of the salt bridge. Discuss factors that can affect your result adversely. Okay, this is the standard electrode potential list. Okay, we are going to check the standard electrode potential for copper. Okay, so copper. Okay, you have to be careful because we are check for copper 2 plus ion reduce become copper solid. Okay, so it's over here. The standard reduction potential for copper 2 plus ion reduce become copper sulfate is positive 0.34. So oxidizing agent, the E-node reduction is more positive, and then process occur as reduction. While reducing agent, the E-node reduction is more negative. Okay, undergo oxidation happen at anode. Okay, so in the standard reduction potential table, oxidizing agent is reactant only, and then reducing agent is product only. So please take note. So the first one, write half cell and overall equation. So this is the example for the first half cell. So anode is zinc. Zinc undergo oxidation. So zinc solid undergo oxidation becomes zinc 2 plus ion plus 2 electron. And then cathode is copper 2 plus ion aqueous reduced to copper solid. Okay, and then you combine, then this is the overall equation. So make sure you check for the number of electron. Is it balanced? Yes, 2, 2. Okay, no problem. And then this is the overall equation. The ratio means the coefficient for the overall equation is 1 to 1 to 1 to 1. It's 1, 1, 1, 1. Why madam emphasize over here? Because right later we need to write down log Q, concentration of product to the power of X, and then concentration of reactant to the power of Y. The XY is referred to the coefficient of the equation. Of course, have to ignore solid and liquid. So we just consider for zinc and copper. So that's why over here is log zinc 2 plus over zinc copper 2 plus for the nurse equation. And then here is 2 electron. And then the E node cell, if you refer, right, the introduction for the part, point number 6, I think. So E node cell equal to E node cathode minus E node anode. Okay, E node cathode is given because it's standard reduction potential of copper is positive 0.34, and then the E node cell is based on the experiment. Okay, so the data that you get from the experiment, the reaction between the zinc and copper, okay, galvanic cell, then you can take calculate the value for the E node anode, means the E node, okay, the standard reduction for the E node zinc 2 plus slash zinc. Okay, this is the value that you need to calculate. So doing the same thing for cell 2, cell 3, and cell 4. Please take note, you have to check for the ratio. Okay, not all the equation is equal to 1. Okay, after you get all the value right, based on your result, you have to arrange the matter in order of increasing strength of reducing agent. Function of the software, I think should be no problem, we discussed before. And then decide the factors that affect your result. So if you check, right, actually there are 3 factors. The first one is the standard reduction potential. Okay, after the standard reduction potential, right, there is another 2. So you go to check. Okay, one is start from C, and another one is start from T. Okay, you can check from the next equation, then you know what are the factors that affect the result. Okay, next part B, electrolytic cell. Okay, this one is from electrical and generate electrical energy change to chemical energy. So a transformer is given over here. So the positive, right, must connect with the carbon. Okay, missing here carbon. You have to jot down carbon as the anode. And then the negative terminal of the transformer connect with the ammeter, and then the ammeter connect with the copper cathode. Then the concentration, right, okay, depends, okay, the concentration, if according to a lab manual, right, is 0.1 molar, so you have to check, okay, on the actual day, we are using 1.0 or 0.1, double check with it. So for part B, you have to jot down the initial mass of the copper electrode. After you clean it with the abrasive cloths, then you have to jot down the initial mass. Okay, remember, please use the same analytical balance. If you use the analytical balance number 2, you keep on using it. So, and then after the experiment, you have to take the final mass of copper electrode, and then final minus initial, you get the mass of copper deposited. Then based on the mass, right, you have to find the number of mole by divided the mass of copper deposited over molar mass. Ammeter reading, so you have to take the ammeter reading. Okay, that always check the functionality of the ammeter, and then the time taken. Okay, according to lab manual is 15 minutes, so it depends on your experiment. So you are using the I is referred to the reading of ammeter, and then T is referred to the time taken for this experiment, must change to second, and then you get the quantity of charge. So the reduction reaction happen over here is copper 2 plus ion, okay, reduce become copper solid. Okay, now you have to start to calculate the Faraday's number. The discussion for part B, you need to state the factors that affect the Faraday constant, and the incorrect value obtained from Faraday constant may be due to the last part, of course, conclusion. So you just answer your objective, the arrangement of matter in the order of increasing strength of reducing agent, and the Faraday constant is. So that's all for this pre-lab experiment 3. So please get ready your report so that next week we can conduct this experiment and straight away fill in the data and then perform the calculation and then hand in the lab report on that day as well. Thank you. Bye.